In the previous video, we looked at prime numbers which ended in 1 and made divisibility tests for them, and also for numbers like 7, which could be multiplied up to give you a number, a product, which ended in 1. So just to remind us of what we did before, if we wanted to form a divisibility test for 71, then we would be using 7 as the operator, and if we took the number 36352, this is the procedure we would follow. We would say 2 7s are 14, and we'd subtract, giving ourselves 3, 6, 2, 1. Then we'd separate off the rightmost column and say 1 times 7 is 7, and subtract that from 362, giving ourselves 355, and then we'd separate off that last column and just say 5 7s are 35, and when we subtracted we'd get 0, which is a multiple of 71, so we have discovered that 36352 is a multiple of 71. But what about numbers which end in 9? I mean, for instance, what about 19? Well, it's very handy that it is just 1 below a multiple of 10. Now, we can write a -1 in the units column and a 2 in a tens column, and then these numbers are the same. With a number system, we usually try to avoid having redundancy, that is to say, 2 different ways of expressing the same number, but in this case we've got some redundancy, but it turns out to be useful. Now, the operator is going to be 1 more than the digit in front of the 9, so we're going to add 1 to that, and there's our operator 2. And let's see what happens. We've got the number 209. Is that divisible by 19? Well, we can separate this off and say 9 times 2 is 18, and in this case we're going to add, and we're going to get 38, which is clearly a multiple of 19, or if you don't believe that, you can separate off the column with the 8 in it and say 8 2s are 16. Add the 16 and the 3, you get 19, so it definitely is. What is going on? Well, of course, if you multiply 9 by 19, you will get 171. But using these negative numbers, we can say 9 times -1 gives you -9, and then you've got your 9 times 20 is 180, so that is indeed 9 times 19. But when you add, this column disappears. So we can take advantage of the fact that we're always going to get a 0 when we add or subtract the multiples using this method. Now let's have a look at another number. Let's have a look at 186,383. And let's ask ourselves, whether that can be divided by 29. Now that can be written as 30 take away 1. As before, we've just got to add 1 to the 2 to get our operator 3. So now let's work along. We can say 3 3s are 9, and when we add, we're going to get 1, 8, 6, 4, 7. and when we say 3 7s are 21, we can once again add, and that's going to give us 1 8 8 5. Then we can take that 5 there in the rightmost column and say 5 3s are 15. And when we add that, we're going to get 203. You might be able to see where this is going, because when we separate off 3 in that rightmost column, because we know it's going to add with a negative 3 to 0, we can say 3 3s are 9, and when we add together 20 and 9, we get 29. So this number, 186,383, is definitely divisible by 29. So this gives us the system, and we can perfectly well now we know how to use either numbers which are 1 above, a multiple of 10, or 1 below, if we remember to add and subtract. And it turns out that in many cases, in the case of 7 there are 2 simple operators, in the case of 13 they're okay, in the case of, let's say, 29, I don't think many people would want to use 26 as their operator and subtract, but some people like arithmetic. So 31's easy. What about 37? 3 37s are 111, and if I multiplied that by 7, I would get 259, which would give me an operator of 26. So I think we'll stick with this one. So we can ask ourselves, now using the whole system as it's needed, 79698, is that divisible by 37? So we're going to be subtracting now, we've got to remember that, and we've got an operator of 11. 8 times 11 is 88, and when we subtract that, we're going to get a 1 there, we're going to get 7881, and then when we multiply that 1 by 11, we're going to have an 11 there, which we're going to subtract, and I don't think we need to do any more, because 777 is clearly a multiple of 111. So that's the system, and there are all sorts of things you can do. I mean, for instance, if you had 13 and say 53, you could multiply them together, and that would give you a number ending in 9, meant to be a 53, and that would give you an 689. So you could use 69 as your operator. Now, the system has been explained, and I hope you've enjoyed that, and either for your own enjoyment or for your classes, I think it would now be simple to make up some worksheets so that students could enjoy these tests as well as the ones that are in the books for 2, 3, 5, 6, 9 and 11. Thank you for your attention.